Okay, so for Math 2, tonight's homework, I'm only going to do number 86 and number 87 because the rest of them seem to be sufficient. 86, for A and B, I don't know what to tell you. You should be comfortable solving proportions now. The only thing I will mention, again, because we had some issues during tutoring, is please make sure you actually put parentheses around anything that has more than one term. And so it's 7 minus y being multiplied by the 4. So it's 7 times 4, which is 28, and then 4 times negative y, which is negative 4y. So you should start to see something like 15 equals 28 minus 4y, and then solving for y. And then the same thing for this one. So I'm going to give you the answers on this one really quickly because I'm not going to waste your time trying to do this. So just please double check that you did them correctly. On, if I can find my paper, that would be even better. On A, you should get y equals 13 over 4, I think is what they got. And then on B, you should get y equals negative 2. Please be advised you actually have to know how to do these. They will show up on your next individual test, guaranteed. And part C, 4 and 2/3 of a month, if I'm not mistaken. No, 4 and 2/3 inches, sorry. How much will he grow in 1 year? 4 and 2/3 of an inches. And then solve for x. If you're still not sure about this one, I can split it up for you really quickly. You have one triangle and you have another little triangle. So you have 3x and 4, and you have 12. We don't know. Please don't put 3 because you don't know what it is. And then you have 8 plus x. So you can do a proportion. You can do 12 and 4. You can do 8 plus x and x. And then from there you could just set up a proportion that looks something like A and B. And if you're doing it correctly, you should get x equals 4, looks like. Okay. If you're still not sure how to do any of these, please read what it says at the bottom. Ideally, at this point, you are comfortable working with these types and can solve them correctly. If you feel you need more, go to Checkpoint 4 materials, try the practice problems provided. They're in the back of your book. From this point on, you will be expected to do problems like these correctly and with confidence. Yay. Okay, so that was 86. And then the other weird one was 87. And the only reason I want to do this is because the first thing I thought about was setting up an area model, which, again, is never a wrong thing to do unless you really can't do an area model. So I thought, okay, well, how would we do this in an area model? And sometimes it might help to put it out. So refrigerators that are produced on an assembly line sometimes contain defects. The probability that a refrigerator has a paint blemish is 4%. Okay, so I thought, okay, if it has a blemish, it's going to be at 4%. If it has no blemish, it's probably going to be at 96%. Okay, well, that works out. And then the probability that it has a dent is 0.5%. Whoa. Okay, so a dent is 0.5%. So then the other part with no dent, which ideally is what you want, is really 95.5%. Okay. So 496 is 100. A half plus 95.5 is 900%. And then what's the probability that it has both a paint blemish and a dent is also 0.5%. Okay, that's a little weird because when you look at it, you're like, okay, it has a paint blemish and a dent is 0.5%. Okay, so let's see if that actually makes sense. Okay, so let's see. We have 0.04 times 0.005. Yeah, that's 0.5%. Okay, see, that's not a half. So that's weird because it doesn't work out. So I'm like, what in the world am I supposed to do now? So then I decided, okay, well, obviously that doesn't work out because that's not a half. So I thought to myself, okay, am I doing something wrong? And I'm like, no, it doesn't. I guess it doesn't work that way. So an area model in this case is not really the best thing to do. So I got kind of stuck. And then I thought, okay, well, I could just kind of fall back on the probability of both of them together, or probability of the union and an intersection. So in this case, a half is what, I guess, if you had done the area model, it wouldn't have come out with a half. So I'm going to cross out the area model because that's not what we were supposed to do. Lesson learned. What is the probability that a refrigerator has a paint blemish or a dent? Can you conclude about what can you conclude about defects on a rectangle? So it reminds you that there's a union model. I mean, a union formula to use, or in this case, an OR. So probability of A plus probability of B minus probability of A and B. So I'm going to take this and we're going to go down here with it. Okay. So I'm going to put probability of blemish. Okay. Or, because you want, what's the probability a refrigerator has a paint blemish or a dent? Okay. So probability of B or probability of D is equal to P of A, the first one. So probability of the blemish plus probability of the dent minus the probability of the blemish and the dent. Right? Okay, well, we know probability of the blemish. The blemish was 4% back from the beginning. Okay, so we have 4%. Okay, plus probability of the dent. The dent was half. Okay, minus, and we didn't find this, it gave this to us. It told us that probability of blemish and the dent is 0.5%. So we're going to subtract 0.5%. Okay. Well, when you're looking at this, you're like, what? I thought to myself, well, these two are the same. So I'm like, okay, well, that's just a zero pair. So half minus 0.5%, well, all that's left is 4%. So the probability of a blemish or a dent is going to equal 4%. So, which is good because that's exactly what they got down over here. Okay. The question is, what can you conclude about defects on these refrigerators? Conclusion, if a refrigerator has a dent, it also has a paint blemish, which is kind of like, oh, duh, which is like if you hit it, you know, it'll have a paint defect too because you've hit it and now it's got a dent and a paint in it. So that's the 87 and 86, which I found interesting. If you have any questions, see me tomorrow. Bye-bye.